Okay, I'm going to pick up where I left off the last day and go through some more examples from the notes. So the first one I'll go through is exercises 1.41 part D. And here it is. So the first thing we're asked for is A times B. So I'll just write that out. I have 1, 1, 1, 1, 1, 1. That's matrix A. And B, 1, 1, 0, 1, 1, 0, 0, 0, minus 1. Now I think this is the first example that I've done where it's not two square matrices. So the first question you must ask here is, can we multiply these matrices together? And it depends on their sizes. So that matrix on the left has got 2 rows and 3 columns. It's a 2 by 3. And matrix B on the right has got, well, it's 3 by 3. Now this works. And when we multiply these together, we will end up with a 2 by 3. So the rule is that those two numbers in the middle, this one and this one, have to be the same. And then when we multiply them out, we're left with that one and that one. And if you think about it, that's the way it has to be, because the first thing I'm going to do to get my element in position 1, 1, first row, first column, I'm going to multiply the first row here by the first column here. And so the length of this across must be the same as the length of this one going down. So the number that we have across here is the number of columns. It's 3. And what we have going down here is the number of rows in the second one. Also 3. So that's why they must be the same. So let's multiply them out. A times B is equal to... Okay, so I'm going to do this in one go this time. So I have this row by this column. So that's 1 times 1 plus 1 times 1 plus 1 times 0. So overall that's 2. Then I'm going to do the one below it next. This row by this column. So that's 1 times 1 plus 1 times 1 plus 1 times 0 again, another 2. So that's down here. Now I'll go across to the second column and the first row here. So again, that's 1 by 1, 1 by 1, 1 by 0, another 2. And below that, I'm going to go second row, second column here. That's actually the same thing again. Now things are going to be a bit different for the third column here. So I'm going to go first row, third column. So that's 0 times 1, 0 times 1, and then it's 1 times minus 1, which is minus 1. Finally, I'm going to do the last row here and the last column here. So again, I have 2 zeros and then a 1 times minus 1. So that is minus 1. And there's your A times B. And as expected, if we count the number of rows, it's 1, 2. So there's my 2. And I have 1, 2, 3 columns. So it is a 2 by 3, as expected. The last part of the question was which, if any, of these are diagonal, unit, or symmetric. Now, this is not a square matrix. It doesn't have the same number of rows and columns, so it can't be diagonal, unit, or symmetric, because those things only apply to square matrices. The next one is A times C. So let's just check, can we do this? So I have a 2 by 3 and a 1, 2, 3 by 2. So we have a 2 by 3 and a 3 by 2. So we can multiply those together because we've got 2 3's there, and what we end up with is a 2 by 2. So let's multiply it out. So I'm going to do the first row first. So I'm going to do first row times first column and then first row times second column. So first row, first column. You might notice with A that it's just all ones. So what I'm going to end up with is 1 times this plus 1 times this plus 1 times this. So what's actually happening is it's like I'm just adding up all these. And then I'm going to add up all these. And then the second row is going to be the same thing. It's just all ones again. So the second row is going to be the same as the first. And again, it's just going to be the sum of all these and then the sum of all these. So let's go to position 1, 1 first, top left. I have 0 plus 1 plus minus 1, which is 0. And then first row, second column, that's this position. Again, it's 1 times 2, 1 times 1, 1 times minus 1. 2 plus 1 plus minus 1 is 2. And because the second row of this is the same as its first row, the second row of this will be the same as the first row, because I'm just going to repeat all those calculations again. So this will also be 0, 2. And that's it, A times C. Next up is B times C. Let's check first if we can do it. So B has 3 rows and 3 columns, 3 by 3, and C has 3 rows and 2. So it's a 3 by 2. So a 3 by 3 multiplied by a 3 by 2 works. It's going to give us a 3 by 2 in the end, so that's fine. So the first thing to notice here again is that B has 2 rows the same. So my answer is going to have the first and second row exactly the same. So let's do first row, first column first. So if you look at this row here, it's 1, 1, 0. So what that's actually going to do to this column here is just add up the first one and the second one. It's 1 times this plus 1 times this and 0 times that. So that's gone. So it's just this one plus this one. So that is 0 plus 1 is 1. Next, I'll do first row by second column. So again, it's just going to be 2 plus 1 and that one is gone. So that's 3. Now, my second row here is the same as the first row. So the same thing is going to happen in the second row, and I'll get 1 and 3. Finally, my third row is 0, 0, minus 1. So what I'll end up with is minus 1 times this and minus 1 times this. And those two zeros, it's 0, 0 there, 0 there. So minus 1 times minus 1 gives me 1 here, and minus 1 times minus 1 gives me 1 here. So there's B times C. So is it diagonal, unit, or symmetric? Well, it's not square. So it's not any of those things. Let's just check for a second. What if I wanted C times B? Well, C is a 3 by 2 and B is a 3 by 3. So here actually, you see, that 2 is not the same as that 3. So that won't work out. You can't actually multiply these together in this way. So you can get B times C, but you can't get C times B. And remember that in general, it matters what order you multiply matrices in. So in this case, you can do it one way and you just can't do it the other way. Next up we have C times A. So that's a 3 by 2 and a 2 by 3. So that works, and we're going to end up with a 3 by 3. So if you look again at A, you see it's all ones. So like when I multiply my first row here by my first column, I'm just going to add up these two. It's going to be 1 times this plus 1 times this. And actually it's going to be the same with everything. So here, position 1, 1, first row by first column, that's just 0 plus 2 is 2. Then first row, second column, I have 0, 2 again, and it's 1, 1 again. So it's going to be the same. So that's another 2. And again, for the third column, another 2. Then we go to the second row. This time, we have 1 and 1. So it's just going to be 1 times 1 plus 1 times 1. So that's just 1 plus 1 is 2. And it's going to be the same across here. Another 2 and another 2. Because this is the same and this is the same. Finally, the third row, I have minus 1 and minus 1. So minus 1 plus minus 1 is minus 2. So that's minus 2, and again that carries all the way across because all the columns here are the same. So that's C times A. So is this matrix symmetric? It's not, because I have 2 here but a minus 2 here. Is it anti-symmetric? Well, no, it's not, because here I have a 2 and I also have a plus 2 here. So if it was anti-symmetric, then one of these would have to be a minus. And is it diagonal? Well, no, it's not, because there are things off the diagonal that are not 0. And it's not a unit matrix either, because that would just be 1, 1, 1 down the diagonal. So this one is not any of those things either. The last one then is B times A transpose. If you count up the rows and columns, you'll find you can't actually multiply B times A. We did A times B, but B times A doesn't work because of the number of rows and columns. But you'll find in this case A transpose actually does work. So let's write them down. There's B, and if you look at A, the first row of A is 1, 1, 1. So the first column of A transpose is going to be 1, 1, 1. And the second row of A is also 1, 1, 1. So that's going to be the second column here. So I talked before about transposes, like flipping it over the diagonal. Now that doesn't work quite as neatly if it's not square, but if you just swap the rows with the columns, then it still works. That's what the transpose is. So A before was a 2 by 3, now it's a 3 by 2. So I have a 3 by 3 and I have a 3 by 2. So that does work. And I'm going to end up with a 3 by 2. So let's multiply it out. This should be quite an easy one to do, because if I look, I have 2 rows the same here. So my first 2 rows are going to be the same in my answer. And actually, these are all the same. So that column and that column are the same. So actually, my 2 columns in my answer would be the same. So let's go through it. First row times first column. So everything in the right is 1, 1, 1. So in first position here, I'm going to have 1 times 1 plus 1 times 1, which is 2. And then because this column is the same as this one, I'm going to do the same thing again for my second position here in the first row. So that's also a 2. Now I can use the fact that this row is the same as this row, right? I'm going to get the same thing again here in the second row, 2, 2. Now the third row is different, so I have 0, 0, minus 1. So 0 times 1 is 0, 0 times 1 is 0, minus 1 times 1 is minus 1. And now again, this column is the same as this one. So I'm going to get the same answer over here, minus 1. And there's my 3 by 2 answer. And again, is it diagonal, unit or symmetric? Well, it's not even square, so no. So this is the last one I'll do today. And we're actually going to do a little bit of algebra in this one. So I'll write down the equation they give us. A squared plus f is equal to A times B times C transpose. So what I need to do is solve this equation, this matrix equation, for f. So what I'll do is I'll subtract a squared from both sides. So a squared plus f minus a squared is equal to a times b times c transpose minus a squared. So, you know, I've taken the same thing from both sides, so that's still a valid equation. So adding of matrices can be done in any order. So I can say that's a squared minus a squared plus f is equal to all this. I'm doing this very step by step now. And then a squared minus a squared is just 0. And so 0 plus f is just f. So f is equal to a times b times c transpose minus a squared. Now that was quite straightforward. I did that in a lot of steps just to do it very, very broken down step by step. You must be careful when doing algebra with matrices because the rules are a little bit different. Like, for example, the order of multiplication matters. But in this case, that works out just the same as it would as if these were numbers and not matrices. So there's f. So I just need to calculate that now given A, B and C. And actually I'll leave this for you to try. So the answer is there in the notes, so you'll know if you get it right. So what you'll have to do is get C transpose, so you know how to do that, swap the rows with the columns, then get AB, then multiply that by C transpose, and then take away A squared, and then you'll have your F matrix. So give that a try now.